Folks, I have an extra special treat for you today, and that is a couple example problems for the Chapter 4 and 5 test. I'd like to write those out for you right now. First problem is it states completely analyze the following function, and it is a rational function. I'm going to start by listing out the things that you should be looking for when analyzing a function. In order to analyze a function, we should be looking at its domain, zeros, vertical asymptotes, holes, horizontal asymptotes, and y-intercepts. But first, we should really factor this thing, this rational function, because that's where our analysis starts. This function factors into a numerator of x minus 4 times the quantity x plus 2 and a denominator of x plus 5 times the quantity of x minus 2. If we start by looking at the domain, recall that we start with all real numbers and then look at any restricted values. Well, we have a denominator here, and our denominator cannot equal 0. So we have to take out negative 5 and negative 2. In interval notation, that domain would look like what I have written here. And again, why did we restrict those values? Because this term equals 0 when x is negative 5, and this term equals 0 when x is negative 2. Now on to the zeros. Anytime our numerator is 0, our function has a 0. So we're going to have a 0 at x equals 4 and x equals negative 2. However, x equals negative 2 is restricted from our domain, so we'll only include x equals negative 4. Folks, I said x equals negative 4, I meant x equals 4. So now on to the vertical asymptotes. We will have a vertical asymptote anytime we have a 0 in the denominator. We have a 0 in the denominator at x equals negative 5. So this is one equation for a vertical asymptote. Now you might be asking yourself, what about x equals negative 2? Well, those two factors cancel, the one in the numerator and the one in the denominator. Anytime we have a pair of factors that cancels like that, that gives us a hole. So we have a hole at x equals negative 2. Now, contrary to what some of you might believe, we are not done just by saying the hole is at x equals negative 2. We now need to find the y-coordinate of that hole. And we get that by plugging negative 2 back into our simplified function. That is the function after we cancel out the factor of negative 2 in the numerator and the denominator. This gives us negative 6 over 3, which equals negative 2. So our hole actually occurs at negative 2, comma, negative 2. In order to identify our horizontal asymptote, we have to look at the end behavior of the function. And that means we have to look at what happens as x approaches positive and negative infinity. Well, as x approaches positive and negative infinity, f of x approaches x squared over x squared, and that approaches 1. So our horizontal asymptote is the line y equals 1. The last thing we have to do here is identify the y-intercept of the function, and that's pretty easy to do. We just plug in x equals 0. F of 0 is our y-intercept. And if you go back and look at the function, notice that, and I'll do this in black here, as we plug in x equals 0, this goes away, and this goes away. So does this and this. So f of 0 is actually negative 8 over positive 10. And of course we can simplify that to negative 4/5. So our y-intercept is 0, comma, negative 4/5. Okay, so now we've completely analyzed the function, but what we can do with this analysis is we can go back and turn it into a graph. So what I'm going to do now is set up an x and y axis so we can graph this function and take a look at how these different features affect the graph. Okay, so the first thing I'll do here is mark my vertical asymptote at x equals negative 5. And my horizontal asymptote at y equals 1. Then I'll mark my 0 at x equals 4. And I'm going to mark my hole at negative 2, comma, negative 2. At this point, I need to know whether the function is positive or negative and where it changes those different values. So what I need to do is create a sign chart, and I'm going to go ahead and set that up right now. So I have my sign chart set up and ready. I showed that there is a domain restriction at -5 and -2. Remember, -5 is the vertical asymptote and -2 is a hole. And then I have a 0 at 4. What I'm going to start doing now is picking test values and seeing how the signs of these different factors change as we plug in our test value. The first value I'll pick is something greater than 4. Why not 5? And all 4 of those factors, the 2 in the numerator and 2 in the denominator, are positive when x equals 5. So I'm going to put a positive mark right here on my sign chart. As I cross over past -4, between -4 and -2, then one of those factors changes from positive and negative. That's the factor of x minus 4. So then I'm going to have one factor that's negative, and the rest will be positive. Well, something unique happens as I pass over x equals -2. I could pick a test point there of perhaps -3. But the sign on these factors in the numerator, these two factors right here, those will always cancel each other out. So when I cross over x equals -2, I'm not going to have a sign change on my sign chart. It's going to stay negative. And then as I cross over -5, the factor of x plus 5 in the denominator will change and to negative, which creates an overall positive value for my function. So there's our final sign chart, and I'm going to use that now to sketch the graph. Here's my completed graph. You'll notice that the end behavior shows as positive both beyond 4 and left of -5. And then I have that 0 behavior in between -4 and the vertical or positive 4, the 0 at positive 4 and the vertical asymptote. This function does not cross the horizontal asymptote, but remember, we could cross a horizontal asymptote. It's only a vertical asymptote that we cannot cross. And the only time it's okay to cross a horizontal asymptote is in the middle of your sign chart. So anywhere in here, it's okay to pass a horizontal asymptote. Out here at your end behavior, not okay. So anytime you're looking at end behavior, make sure you do not cross your horizontal asymptote. And that's it for this problem.